so we're going to look at air pressure, okay? It's something that we all take for granted, is the fact that our bodies are pretty good at withstanding atmospheric pressure. But it's very important for us. When we breathe in, breathe out. Okay, what's happening is my ribs, okay, are being pulled up by my intercostal muscles every time I breathe in. My diaphragm is pulling down. That's increasing the volume of my lungs, okay? Now, because my lungs volumes have increased, that's going to mean that air pressure inside my body has decreased, which is going to draw air from the atmosphere inside my body. It's pretty important if you want to respire and live and be alive. When I want to breathe out, my lungs go down, my diaphragm relaxes, and that decreases the volume inside my lungs, which acts like a little bit, if you get a pop bottle and squeeze it, okay, it's going to increase the pressure within my body, and that's going to force the air the only way it can go, which is back up and out in my body. It's very, very important for gas exchange. But when you talk to people about it, it almost sounds a little bit too out in the air. It's not something that we can see. So I'm going to use a quick demonstration to try and show how important air pressure is and how it works. Okay, we're going, cool. So if you want to do this at home, you're going to need some very hard-boiled eggs. You're going to need some kind of glass bowl would be better, but I've got a little vase, and the egg doesn't fit inside the vase. If I was to try and push this in with my big meaty thumbs, I would pretty much trash the egg, but we don't want to do that. We want to try and keep the egg whole. It's a practical kind of joke thing that people tend to play on each other, and you always see it in the little homemade science handbooks. In order to do it, I'm going to use these things, matches. What we're going to do, if I take a couple of matches out, I'm going to try and light 2 matches at once, drop the matches in, okay, and what's hopefully going to happen is, as the matches burn, they're going to use up the oxygen inside. That's going to decrease the pressure inside here, which is going to create more air pressure, well, on top of our egg. As it squeezes down to try and reset the balance, it's going to push the egg, hopefully, inside our glass jar without damaging it. Let's see if it works. So if I take my egg out, keep it in one piece, strike my matches, drop them in, drop the egg on top, cash back. Right, so it works very, very slowly. Hopefully when you do it you get a bit more kind of a pop sound and it drops itself in. If you do have a straight neck bottle, you can blow on the inside when you turn it upside down to get your egg back out. Unfortunately, because I've got quite this round bit here, when I tried this earlier it didn't work and I had to cut it in half. But if you can get it to work, it looks quite spectacular as it pops back out. Okay, so that experiment was pretty good, but not as spectacular as probably we can have. Now, what I want to do is I want to show what happens using a can. Coke cans probably work best, but unfortunately this is all we've got around. But air pressure can be quite spectacular, quite destructive. If you Google on YouTube and you look around, you can see some videos of deep sea pipes where the air pressure is different, that suck in crabs and do stuff like that. And those are really big, straight in your face examples of when air pressure goes wrong, how destructive it can be. This one, hopefully will be the same thing. So what you need a can, a smaller can would be a bit easier, something to hold the can with safely, because safety is always important, and you need some cold water and a heat source. So I've got a stove. Have a look. Okay, so what I'm going to do is I'm going to turn the ring on. There we go. Okay, I'm going to hold the can gently like that, and I'm going to heat the bottom of the can. Now what this is doing is it's warming the little bit of water I put inside the can, okay, so it's going to make some steam. Now when we get enough steam inside and we start to see it coming out, and you should be able to hear it a little bit like an old-fashioned kettle, what that means is the pressure inside the can is increased, because the steam, as we all know, you heat something, you are transferring the thermal energy into whatever you've got, and that's going to increase the kinetic energy of any molecules. Because they've got more kinetic energy within the can, that means it's going to be pushing more and more on the outside walls of the can. So if we didn't have the can open, we may run the risk of actually blowing the can up, which isn't safe, and we don't want to do things that aren't safe. As it is, this is perfectly safe at the minute, provided I don't burn myself. What I'm hoping will happen is, when we do have enough pressure inside, I'll put the can in the cold water, changing the temperature of the gas inside, which will then condense because it loses kinetic energy. But what happens is, the edge of the can, the hole, the orifice, is going to be trapped by the water, so no air can go inside to equalise the pressure. Because of that, we're going to have a pressure difference between the atmosphere on the outside and what's inside the can. Let's see what happens to that pressure difference. So we're getting some steam coming off, I don't know if you can see that. Okay, starting to get a bit of noise. What I'm going to do is I'm going to turn the ring off so it's safe. I think that's it. And then very quickly, and hey presto, it works. Okay, the pressure difference on the inside to the outside meant the atmosphere literally crushed the can. But that doesn't happen to us because our breathing, our body, maintains this balance with the environment outside, and so we don't get crushed. We're an random fact, okay? The amount of air pressure on our body at any given time is about the same as the weight of a small car. Now the important thing to bear in mind in that is cars are pretty heavy. Our body deals with it naturally. But, and here's the interesting fact, the reason why our body deals with it is because we exert the same amount of pressure outwards. So every time you're walking along, your body's exerting the same amount of pressure, the size and weight of a small car, to the atmosphere around you in order to stop your body crumpling as our can did. Thank you for watching. Okay, so that worked really well. So if you want to come and have a look at that can, let's take on a little bit of water. But look at just how crushed it actually is. I didn't expect it to work that well. You know, when I do it normally in a lesson, it doesn't crush that flat. But then I did leave this on quite a long time because I was doing a lot of talking. That's incredible. It worked really well. Okay, so the last experiment with the can worked really, really well, which is a bit of a curse on this one, maybe not working as well. But what we're going to do is we're going to film it from a little bit closer, just so we can see the moment that it crushes a lot more clearly. Okay, so Dev, if you want to go down, okay, and I'll relight the fire. Okay, so if I turn that towards the camera a bit more, hopefully you'll be able to see when it's whistling off, when the steam's coming out. I mean, you can always see it a little bit straight away, but we'll leave it as long as possible to get as much coming out as possible. Now again, if you're going to do this at home, the important thing is to make sure, I mean really I should be wearing an oven glove, but I am quite experienced with doing this practical, so safety first, always, 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 always. The biggest issue I see when we're doing experiments is people aren't taking precautions, okay? It only takes it to go wrong once. So, preaching over. Right, so we've got air pressure building inside because we're heating up the molecules, okay? So it's again, it's a transfer of energy, okay? We're if you want to take it the whole way, we've got chemical energy in our gas being turned into or converted to thermal energy on the stove, converting our molecules to having kinetic energy. I got a little bit disrupted there because I don't know if you can hear. Do you want to bring it a bit closer? Okay, you can hear the heat inside. Okay, so you know that there's heat building. I can also feel it coming along the tongue, so I'm going to turn this off the right way this time. Okay, so Dev, if you want to just focus on the pan, and I'll bring this in. 3, 2, 1. Okay, that one worked even better. Now this is going to be quite cool because the water cools it down so quickly. But if you look, it does take on an awful lot of water. And that's pretty flat. I mean, that's like a supermodel can now. But yeah, air pressure's awesome.